So, good morning, everyone, and welcome to this lecture number 2 on the center of mass. This is, we'll try to understand the motion of center of mass, find the center of mass. In the previous class, we had seen the center of mass of some of the, what should I say, geometrical entity, semicircular ring, annular ring, semicircular half ring, disk. Why is this written semicircular ring? See, this is not semicircular ring, this is semicircular disk. Solid hemisphere is always solid, hollow. Then we have seen a triangular plate, solid cone, hollow cone. Everything that was possible has been given to you. And they cannot ask anything apart from this. Something of this nature will come to you. I mean, any one of these directly they might ask you a question. So we have covered almost the entire majority of questions. Now what they might ask you is what is the center of mass of composite figures. Now how do you find the center of mass of composite figures? Center of mass of composite figures. When I say composite figure, that means the figure consists of more than one geometrical thing. So you can find the center of mass like this. The position of center of mass, I will write in vector form. You can write it in x, y, and z form. That will be equal to m1 into r1, where m1 will be the mass of that body, r1 vector will be the position of center of mass. So I can write the summation of mi divided by summation of mi. Do you understand what I'm saying here?
Yes, sir.
So basically, you find out where all these masses are, where their center of masses are, to multiply them, summate them, and divide it by the summation of the entire thing. Do we understand this?
Yes, sir.
I can make you understand with this with a small question. For example, this is one rod and this is another rod. Rods are kept like this. You can take your origin, because to find out the center of mass you must be told where you have to take your origin, because if you change your origin your coordinates will start to look a bit different. I don't want them to look different. You have got two rods. Both of these rods are having mass m and length l. Both of these rods are having mass m and length l. Find the coordinates of the center of mass of this. Find the coordinates of center of mass of this composite structure. Your origin lies here. You have 2 minutes to do this.
పాయింట్ ఇచ్చారు సెంటర్ ఆఫ్ మాస్ M ఒకటి L ఒకటి కదా, ఇక్కడ కూడా x కోఆర్డినేట్ లో M L ఉంది, y కోఆర్డినేట్ లో x అంటే M L ఇక్కడ 0 క్లారిటీ ఏదో వచ్చినప్పుడు ఎక్కడ 0 x కోఆర్డినేట్
Yeah, shall I do it?
L by 4, L by 4, sir.
L by 4, L by 4, that is correct. So how are you supposed to do this? You locate the center of mass of both of these bodies. The center of mass of this body is here, and the center of mass of this body is here. Now, I go about locating the center of mass of this diagram. I hope you can see it. Now you can see it. Now I go about locating the center of mass of this. So x position of the center of mass will be m1 into x1 plus m2 into x2 divided by m1 plus m2. Yes or no? Let me call this body as body number 1 and let me call this body as body number 2. So let us now locate the x coordinate of the center of mass. The x coordinate of the center of mass x1 here is L by 2, yes or no? And m1 here is m, correct? What about this? x2 is 0 because the center of mass lies on the line itself, yes or no? So I can put the values m into L by 2 divided by m plus m is 2m. So I end up with L by 4. That is the x position of the center of mass. Similarly, I can find the y position of center of mass m1 into y1 plus m2 into y2 divided by m1 plus m2. And how will you get that? Here in this case, this will become 0 and this y2 will become L by 2. Yes or no?
Yes.
So if you put the values again, you will end up with the same answer, L by 4. So the coordinates of the center of mass of this diagram is L by 4, L by 4. Do we understand this?
Yes, sir.
Okay. Okay, now I have this question.
M2 x2 into y axis లో x0.
This is a cone and this is a hemisphere. When I see a cone is always solid. When I see a hemisphere is always solid. The radius is r, as you can see, and the height, let us say, is 3r. Solid cone, this is a combination of solid cone and a hemisphere. I hope you understand this, yes or no?
Yes, sir.
Now, which coordinate of center of mass we should locate? Should we locate the x coordinate or should I locate the y coordinate?
Y coordinates.
Y coordinate. I should also tell you the mass. So let me say that I am not telling you the mass here. They are made from the same material. They are made from the same material. Do you know the volume of a cone?
Sir, volume of a cone.
Do you know the volume of a cone?
by 3 pi r square. చూపిస్తున్నారు 1/3 pi r square.
Yes, what is the volume of a cone?
1 by 3 pi r square.
1 by 3 pi r square, sir.
Volume of a cone. Volume.
Yes.
What is the volume of a cone?
1 by 3 pi r cube.
1 by 3 pi r square h. That is the volume of a cone. Okay. So they are made up of the same material. They are made up of the same material.
Okay, sir.
Solid cone and a solid hemisphere, they are made up of the same material. There are two ways in which I can ask this question. I can tell you what the masses are, or I can tell you they are made of the same material. So what I'm telling you is both of them are made up of the same material. Locate the center of mass. Which coordinate of center of mass we should locate?
My
Why? Because we already know that if I take my coordinate system correctly, for example, if I take this as my coordinate system, if I take x-axis like this and y-axis like this, and I take the origin here, the x coordinate lies at the origin. Don't have to worry about the x coordinate because we have the symmetry. You only have to locate the y coordinate. Formula is there with you. Let's hope that you are able to do this. 2 minutes you have. Let me know once you are done.
X and y coordinates. మొత్తానికి కలిపి అన్నీ తీసుకున్నాను. Columns కూడా ఉన్నాయి. ఇక్కడ నేను coordinates kind of తెలియదు కదా.
Shall I help you? Oh, we are good. Huh?
We are doing so.
Okay. Try. There is nothing new in this problem that you cannot do.
Sir, 7R/9.
7R by 9. I don't know the answer because I've just made this question on myself, so I'll have to check it. Everyone got this? Because I'll need to check it. I will check it with my own hands. Shall I do it, then? Shall I do it? So how are we supposed to do this? How? We are going to find the mass of this cone. How much is the mass of this cone? I assume that the density here in this case, the volume density is rho. So it will be rho multiplied by 1 by 3 pi. Radius of this cube is radius is r square multiplied by height is 3r. Yes or no?
Yes, sir.
So it becomes 3 cancel, rho into pi into r cube. This is the mass of this one. What is the mass of this one? Rho multiplied by the volume of this 2 by 3 pi r cube. Yes or no?
Yes, sir.
Then I locate the center of mass. Where is the center of mass of this gentleman? Solid cone.
H/3, sir.
Pakka? Or h by 4? Two
H
answers. Two answers we had seen.
H/4, sir.
H by 4, sir. Pakka? Chalo. I wanted to show it to you, but you are telling me the right answer, so there is no point of showing it to you. H by 4. So this is located H by 4. What about this sphere, hemisphere? Where is the center of mass located? You don't remember it. Anyone can read it and tell me. A third standard student can read it and tell me.
3R/8, sir.
3r by 8. 3r by 8. That's it. So I just find the y coordinate of the system. Y coordinate of the system is m1. I'm calling the cone as m1. So rho into pi r cube multiplied by h. Height is 3r. So 3r by 4. Yes or no?
Yes, sir.
Plus m2 is rho into 2 by 3 pi r cube multiplied by what is the location of center of mass? What should I write? 3r by 8. Yes or no?
Yes, sir. 3R/8.
3r by 8. Well done. Divided by rho into pi r cube plus rho into 2 by 3 pi r cube. This rho will get cancelled, so you actually did not have to use rho. What is this thing that you are getting? If you look at this thing, this is the volume V1, so you can make a formula. This is the volume of V1. This is the volume V2. So it is V1 into Y1 plus V2 into Y2 divided by V1 plus V2. Are you getting my point? Rho was just going to get cancelled. So you solve this and you'll end up with the answer. What answer are you getting? Yes, doubts on this? Did you do it this way or did you do it some other way? This pi r cube, pi r cube, pi r cube, pi r cube will get cancelled from everyone, everywhere.
Sir, I have a doubt, sir.
Yes.
Sir, here under coordinate of the center of sphere should be taken negative or positive, sir.
I asked you, you said 3r by 8, I wrote 3r by 8.
Sir,
I asked you what is the coordinate of the hemisphere, you said 3r by 8, so I wrote 3r by 8. Or was I wrong?
sir, no, sir. That's coordinate is taken as negative or positive, sir.
I asked you what is the coordinate of center of mass of the hemisphere and you said 3r by 8, so I wrote 3r by 8. Is it wrong?
Sir, it should be minus, no, sir.
So you should have told me it is minus 3r by 8. I just write what you said. It is below 0, it has to be minus, so your answer was definitely going to come wrong. Remember it. This is how you remember things. When you do a mistake, you remember it. So remember it, it has to be taken as negative because it is negative, it is below 0, it has to be negative. There is no point of calling it positive. It cannot be positive. I hope you understand this and you remember this.
Yes, sir.
So now we have made a formula. So if we have volume involved, addition of two volumes involved and they are made up of the same material, you can make the formula or shortcut formula like this. The shortcut formula for the position of center of mass, I write in vector form, so you can write x, y, or z. You can write it as summation of vi. You understand the meaning of vi? Vi ri vector divided by summation of vi. Do we understand this? When things are made up of same material, but they have volume. Do we understand this?
Yes, sir.
Similarly, you can have things made up of area. You can have a square plate and a disc made up of the same material. In that case, the formula will become ai ri vector divided by a summation of ai. Are you getting my point? Huh?
Yes, sir.
So then you can do it in that way. Do we understand this?
Yes, sir.
Okay. Now comes the next question. And the next question is like this. And I'll show it to you snapshot. Whenever in the question you see lamina, lamina means it is a two-dimensional body. Do we understand this?
Yes, sir.
Lamina means it is a two-dimensional body. So this is the question that we have. Find the position of the center of the mass of the uniform lamina. The radius of this lamina is given as A. You can take it as R. And you can see the origin is at the center of the lamina. You have to find the center of mass of this lamina. And you have 2 minutes to show your talents. Yes, but any answers? Taking so long?
Minus a by 2. Sir, it's minus a by 2.
Minus a by 2. Let me check. I have the answer for this one because this is from the sheet that I have. Minus a by 2. It is absolutely wrong. Try again. You should be able to get this. 2 minutes you have. Still left. How are you doing it? I don't understand. A by 2. How did you get a by 2? Minus a by 2. Shall I do it?
Yes, sir.
So how you have to do it? Basically what we have is we have a disk with a hole. Some area has been removed. Some area has been removed. So how can you solve a question of this nature? What you assume is, you assume it to be a combination of two bodies. One is body number 1, which is a complete disk. Body number 1, complete disk. Body number 2 is a disk which has a negative mass. And this is, we know, as a concept of negative mass or negative volume or negative area or negative current. We will be using this whenever we have to take something out from a body. If this is a square plate and you need to take something out from this body, say for example this much portion, so what do you assume is, or it has a hole like this, what do you assume it? You assume that one body is the complete body and then you put a negative mass of this much area or volume. Do we understand this?
Yes, sir.
Since the mass is negative, the formula becomes like this. And again, write the formula in the vector form so that you can find out the x, y, or z coordinate. The formula now for the vector form looks like this. M1 into R1 minus M2 into R2. Why I'm writing vector sign over M2? Divided by M1 minus M2. Do we understand this? Why minus M2? Because the second body that we are making is made up of negative mass. Do we understand this?
Yes, sir.
Now, here in this case, this body has been cut off from a body which is made up from the same material. Yes or no? And here it is made up of area. So here, instead of writing mass, you can simply write A1 into R1 minus A2 into R2 divided by A1 minus A2. Are you getting my point? This question and the previous question are exactly similar. In the previous question, we were adding something. In this question, we are subtracting something and therefore the negative sign. Do we understand this? In the first question, the formula that I gave you and the question that we did was adding something. We added something. In a cone, we added hemisphere. We could have subtracted a hemisphere from a cone. In that case, the formula becomes minus. Do we understand this? So this is how you do it. If you do it in a volume, so the same question could be said in this way. This is a sphere, solid sphere. And from that solid sphere, some portion of the sphere is taken out. What is the center of mass? So in that case, the formula still remains like this, but in terms of area, instead of area, you will get volume. V1 R1 minus V2 R2. Why I'm writing it in terms of R1 and R2? So that you understand that whether it is the value of X or value of Y or the value of Z, you can find out from V1 X1 minus V2 X2, V1 Y1 minus V3 Y3, V1 Z3 minus V3 Z3. Do we understand this? Now, if I apply this formula here, this is the lamina, so this is an area. So A1, the area of the entire figure. How much is the area of the entire figure? It is
Pi square, sir.
pi r square, but the center of mass is at the center, so pi r square multiplied by 0 is going to be 0. Yes or no? So let me write 0 straight away. Are you getting my point? Yes or no?
Yes, sir.
Then the minus sign is automatically there, so I put the minus sign. Area of the second body. The second body has an area, has a radius of a by 2. Yes or no?
Yes, sir.
So area becomes pi a square by 4. Yes or no?
Yes, sir.
And the location of that center of mass is the center of that. And the center of that is where?
A by 2.
Center of mass is at the center. So it is a by 2. So again multiplied by a by 2. Are you getting my point? How much area is remaining?
sir.
Total area is pi r square minus pi r square by 4. So the total area that remains is 3 pi a square by 4. Yes or no?
Yes, sir.
And that is the answer, my dear friends. Pi a square will get cancelled. This 4 and this 4 will cancel. And you have your entire answer as the which coordinate you have to find out? X, Y, or Z? Which coordinate you have to find out here? X, Y, or Z?
X, sir.
X will be minus a by 6. Do we understand this?
Yes, sir.
Yes or no? No, yes. I'll give you one more question on this. So that this concept of negative mass or negative area or negative volume remains with you. Same question, but put in a different way. What is a different way? I hope you understand. Now this is a sphere of radius A. Locate the center of mass of this. From the sphere of radius A, I have taken a by 2 radius ka sphere out. I hope you understand this. Yes or no? You have 2 minutes to show your talents.
Sir, it's minus A by 14, sir.
Okay, let's wait for everyone. Everyone got the answer? Shall I do it now?
Yes, sir.
I mean, you want me to do it or you have done it and you got the answer? Are we getting the same answer or are we getting different answers for different people? Yes?
We did not got, sir.
Why we did not get? What's so enterprising about this question? It is a very simple question. So we just put the formula, get the answer, and stay happy. So what the x position of center of mass will be V1 x1 minus V2 x2 divided by V1 minus V2. This term will become 0 because for the first body, the center of mass lies at the center. Yes or no?
Yes, sir.
What is so difficult here? Don't understand. You don't know how to calculate the volume of this? 4 by 3 pi into radius is a, so a cube by 8. It is so difficult. Multiply by where is the center of mass of this? It is at the center of this, a by 2 divided by how much area is left, how much volume is left, 4 by 3 pi a cube minus 4 by 3 pi a cube by 8. You can't multiply, subtract, divide. What is the answer you are getting?
Minus A by 14, sir.
Why it is so difficult for you to do this? I don't understand. Why it is so difficult? Difficulty is only in our heads. How much?
Minus A by 14.
Minus a by 14, 1 4.
Yes, sir.
So as you can see, it is pretty damn simple from the way I look at it. Yes or no?
Yes, sir.
I hope you are confident enough of doing it now.
Yes, sir.
Okay, let us move on to the next heading. Remember, they can make more composite figures. They can make the reverse of question number 1. This question number 1, they can make the reverse of it. What do I mean by reverse of it? From a cone, they can take out instead of adding the hemisphere down below, they can take out a hemisphere from the here. Do you understand what I'm saying?
Yes, sir.
They can do it this way. This remains same. This instead of minus, it becomes minus here and this becomes plus here. Do you understand this?
Yes, sir.
Yes or no? And here instead of plus, it becomes
Minus.
okay. Understand the concept? Then entire thing is very simple. The next heading is motion of the center of mass of the system. Motion of the center of mass of the system. That is the heading. So we already know number A, the position vector of center of mass is nothing but MI/RI summation divided by summation of MI. Yes or no?
Yes, sir.
If I differentiate equation number 1, what will I get? If I differentiate equation number 1, what will I get?
Velocities.
Velocity of center of mass summation of MI Vi vector divided by summation of Mi. Summation of Mi simply means the total mass of the system. If I differentiate it once more, then what do I get?
Accelerations.
Acceleration of center of mass is Mi Ai vector divided by summation of Mi. Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now this formula, now this is summation of Mi. This is the total mass of the system. If I multiply the total mass of the system with the velocity of center of mass, if I multiply mass of the system, let me write it as capital M. Do you understand the meaning of capital M? If I multiply capital M by the velocity of center of mass, this becomes the momentum of the system. We have already done momentum, yes or no?
Yes, sir.
So momentum of the system is summation of MIVI, and MIVI is momentum of individual body. So it becomes summation of PI. Do we understand the meaning of this?
Yes, sir.
Is it getting above or at saying bye bye, bye bye, I'm going? Don't worry about me.
Done, sir.
Okay. Now, if we look here, this summation of MIAI, M1 into A1 is the net force on body A, body 1, net force on body 2, net force on body 3. Now, when we add up all these net forces, some forces will be external to the system and some forces will be internal to the system. When we talk about internal forces on the system, those forces will exist in pairs. If a body 1 is applying force F1 on body 2, body 2 will apply the same force in the opposite direction. Yes or no?
Yes,
So these
sir.
internal forces will be 0. So remember the internal forces, that is the point that you must remember. Summation of F internal for a system is always equal to
0.
the internal forces will cancel each other out. So this green thing, which will have internal as well as external forces will cancel out, and this summation will become something like this. It will become F external, total F external, that will be equal to mass of the system multiplied by acceleration of center of mass. And that is why we say acceleration, that is why we say center of mass is that point where we can assume that the entire mass of the body is concentrated and whatever forces are acting can be supposed to be acting on that point, and the motion of the center of mass gives the translational motion of all these bodies because of this equation. Do we understand this?
Yes, sir.
So this is what you need to know about the motion of center of mass. We will go ahead. I was looking for a question here where you can find the velocity and acceleration of center. Okay. We understand this, yes or no? All these equations?
Yes, sir.
This is the first question for you. On this center of mass ka concept, a jeep of mass 2400 kg is moving along a straight stretch of road at 80 kilometers per hour. It is followed by a jeep of mass 1600 kg is moving at 60 kilometers per hour. How fast is the center of mass of the two cars moving? You have to find the velocity of the center of mass. I hope you can do this. Yes or no? No, yes. Huh?
Yes, sir.
Do it. So how do we do this? Should not take so much of time. Huh?
1 minute, sir.
If it is taking so much, that means you are not doing it correctly, probably. Okay, I'll give you time. That's the
70
difference.
72 kilometer per hour, sir.
72 kilometer per hour. That is the correct answer. What you got to do, this is motion in 1D, so you can take this direction as positive. This velocity is also positive. This velocity is also positive. You don't have to convert meter per second, kilometer per hour. You just have to put the formula. Velocity of center of mass can be written as m1 v1, motion in 1D, m2 v2 divided by m1 plus m2. Yes or no? No, yes.
Yes, sir.
Let us quickly move on to one more question, fatafat, before we. Okay, do it fast. Fast. This one. A 2 kg particle has a velocity v1 and a 3 kg particle has velocity v2. Find the velocity of the center of the mass of the system. Yes, I still get the answer.
7 by 5 I cap plus 12 by 5 J cap.
7 by 5 I cap plus 12 by 5 J cap. Everyone got this answer? Should I do it?
Yes, sir.
Everyone?
Yes, sir.
Okay, then I shall not waste any more time. You just have to apply m1 v1 plus m2 v2 divided by m1 in vector form here. Okay.
Yes,
This
sir.
is the question that I'm going to give you for homework because you might not have that time right now to solve it. So note down this question and tell me the answer in the next class. This is the question. A pulley fixed to a ceiling carries a string with bodies of mass m and 3m attached to its end. The mass of the pulley and the strings are negligible. Don't write the entire question. Just draw the diagram. That is good enough. Friction is absent. What is the acceleration of the center of mass of the system? G by 4 downward. Downward is taken as positive. Downward is taken negative, I guess. G by 4 downward, G by 4 upward, G by 5 minus G by 5. It's a pulley mass system. Masses are 3m and 4 and m. You have to find the acceleration of the center of mass of that system. With this, I will end today's class. The next class, we'll continue on with the motion of the center of mass, and we'll see more interesting thing. Law of conservation of momentum will come. Then your collision will come, and we'll try to wind up as soon as possible so that we can wind up your mechanics and move on to some greener postures where you will have more what? More scope of scoring. I don't find mechanics so interesting in terms of scoring, but I hope if you have done all the problems that we have discussed in the class seriously, I can assure you that problem in your JEE is going to come from that part itself. Okay. So on that note and promise, I will take your leave and the class is dismissed. See you in the next class tomorrow. We'll continue with this. Take care.
Thank
Have a
you,
nice day.
sir.
Bye, beta. Any doubts, please ask me. Please don't be shy in asking your doubts.